Hello. My name is Martin, and I'm here today to speak you about an interesting topic, which is cloud workflows and the Eventarc system, which we will cover in the second part of the talk. So we are going to see what is cloud workflows, and eventually we will see how and why we are calling the Eventarc system a Swiss Army knife for service orchestration. Basically, it lets you to open a lot of things in the cloud industry and so on. So let's start. So as I said, my name is Marton. I'm Hungarian, living in Romania. My top contribution in the community world is that I answer a lot of questions on Stack Overflow. I strongly answer a lot of questions, and I wanted to actually pass the 200,000 mark on reputation points, but there are still missing pieces, so I need 1-2 days in order to pass it. Other than that, I'm a GD on cloud technologies since 2016, and I work a lot with Google Cloud products especially. I'm not a Google employee. I'm still based in Romania. I work for a software engineer company as a software architect here. And I publish also articles on Medium Wall, and there is no paywall. You can check it out. Slides will be available after the session shortly on SlideShare, or you can ping me anywhere, anytime on Martin Kodok in Twitter, and we can chat about that as well. Good. So let's see what we have for today. So we are going to see what is cloud workflows, what is Eventarc. I will show you some practical use cases, and hopefully you will see the benefits of these awesome products that connects a lot of services together. At any time, if you have questions, use the chat, add it there, because that way I can refer back to exactly when the charts or examples are on the screen and so on. So hopefully we will get a lot of questions and see what we are up to today. So cloud workflows, as the name suggests, it's a workflow system. It means that you can actually do steps in it, and it's part of the Google Cloud portfolio. So it means that it's a managed product. You only need let's say your billing activated, you don't need a sysadmin, you don't need to install anything. It's a managed service, and it connects with a lot of underlying infrastructure, either inside the cloud or outside the cloud as well. Essentially, you can orchestrate, connect, which if you don't know the orchestrate English word, it means that connects eventually. You can connect any Google Cloud API, any SaaS API, or external or private API. So whatever is callable under HTTP protocol, it can be connected. So the workflows actually sits on top of serverless, on top of Google APIs and external APIs. From serverless compute, or let's say anything that's part of the Google Cloud and it has an API, it can actually close that door. It can interact with and program it, read out data or send data or do things of it, like starting a virtual machine or increasing an autoscale parameter or reading out based on metrics some status variables, some metric variable, and deciding a thing to do next, and call that using the APIs as well. And of course, the external APIs, just name an example, SendGrid to send an email or do a tweet or do a Slack job notification, whatever that can be done as well. So if we want to say more about what is GCP Workflow, it's a step automation as a service. So whatever means that if you have a HTTP service, API, REST API, whatever we call it, it can actually connect the dots for it. And we say that it's a serverless thing because you don't need to provision GCP Workflow at all. It has a declarative workflow language, which means that we are basically using YAML, but the same syntax is available as a JSON hierarchy tree as well. It has decent pricing, only 1 for 100,000, 2.5 for 100,000 external calls. And this is actually pretty amazing because it's very cheap service to actually connect services. It has built-in decision, support for external API calls, out-of-the-box support. And my favorite is that it integrates with any Google Cloud product without worrying about authentication. So if you develop in the cloud, you know that you have the service account keys, and giving the service account the right permission, actually it can connect with any Google Cloud product. You don't need to actually have a library or build out, for example, let's name a few, Node.js library or a connector in order to build out something that will be on the market for 2 years. After that, you need to update it because a new major version came out. So the YAML syntax is actually pretty straightforward. It will be there for 10, 20 years, and you don't need to upgrade that every major versions as well. Quickly jumping to sample workflows. In the beginning, there will be something basic one, like for example, you could have a scheduler which at 9 a.m. starts a compute engine VM. You would have a wait phase for 60 seconds in order to boot up, and eventually, if it doesn't, then log the event in the cloud log system and notify the team on the Slack that something didn't happen. Which is just a basic example, like a hello world thing to see. Here, the workflow is being started based on a scheduler event. Next, when we have the e-commerce invoice generation, you could have receive an order when you have the app, and the workflow itself is the orchestrator of your services. So you could have a create invoice tab, a generate PDF, send PDF via email steps. All these could be done by services that you have programmed either on App Engine, Cloud Run, Cloud Functions, and these systems as well. So here in this example, we are orchestrating microservices that you developed, and the orchestrator itself is the cloud workflow system. Code example, because we are developers, we want to see code examples. In order to see code examples, let's first see the anatomy of a cloud workflow and how we are actually passing between the state machine and what workflow can offer. Well, eventually, when the workflow is being executed, there is a param section that you can pass arbitrary data or event data, whatever, and then there is a running phase which have multiple steps in it. And the running fail can go actually into a timeout or into a succeeded state. The timeout state can actually go into the failed one. There is also this underlying callback system, which we will discuss later on some other slides. But basically, you have a starting point, a few steps, and succeeded or failed status for it. Basics, just going around for the basics of it. For those who never work with cloud workflows, the Eventarc system will be the second part of the talk. So essentially, we need to identify that when we are developing a cloud workflow, we define steps. In those steps, basically, there are HTTP calls, either GET or POST, or via the connectors. In order to do some logic, you need to segment 2 steps. The first step is getting out the data. The second step, do some action on it. There are possibilities to do sub workflows, which means that, for example, sending an email could be a sub workflow, and you only call it by name and adding the parameters to it. Then you can connect anything on cloud or external services using the HTTP syntax at all. Just a hello world example. Here you have 3 steps: get current time, read Wikipedia, return result. So essentially from Wikipedia, to get the current time, we are just putting here a cloud function example that returns a JSON document, and that JSON document is written into current time variable. And after that, we use the API of Wikipedia, we do the open search action, and then we pass a a string to it. The string is being read from the current time, body, day of the week parameter as well. The result is into the wiki result, and also it goes to the body. Another example, which was the sub-workflow system. The sub-workflow system is that you have it defined after your main steps. Here are the main steps. You have after defined, you have a name, you have the parameter of it. And whenever you want to actually use that in your steps, you just call the name of the sub-workflow, the arguments to it, and the output that you want to do. So basically, this is the easier syntax to actually incorporate recipes from internet, or actually to develop code that's reusable between the cloud workflows as well. Okay, and now before going into actually some rich and new features of cloud workflow, let me show you around on the interface for those who are beginners in this. So here we have the cloud workflow system. Essentially, you can get to this page by typing in the search bar workflows. You have this screen here, and for example, you can use the interface in order to create your workflow. Like let's check this Wikipedia example. Here you have some metrics, or normally I didn't execute it right now. So let's see, in the edit section, we have the name of it and the service account, and here is the algorithm that was previously in the slides as well. You see here a visualization prepared, but of course workflows can have also conditioners, and it can be bigger if you do some actions on it. So as you develop the workflow, you could have a visualization. But as being a developer, we also want to actually work in the code itself. So here we have VS Code, and let me open some basic examples for you. Like there is an example here with shortening a link shortener, and let's see if we can actually run it. So what we have here, let's see if this is going to zoom out. Okay, zoom in, good. That's good. So what we have here, first of all, so we have VS Code. We have the G-Cloud utility installed in order to interact with the Google Cloud Platform. There is an extension which signals which is the current project in GCP, and I will advertise that extension. This is the extension, GCP Project Switcher. It happens to be my extension, so actually I published this to the market in order to have you in the status bar the current project that you work with, and you can actually switch project using the GCP Project Switcher. In case you need to install it and work with the Google Cloud Platform, I just pasted it into the chat in order to install it as well. So we are on our Marston data project, and now I want to deploy this project. Here in the left, you see that I have different actions to it. So in the VS Code settings and the tasks, you can define in VS Code tasks. For example, the deploy is G-Cloud Workflow Deploy. The name referred, the name of the workflow that we are going to use referred from the file name and the source file. So essentially, when I want to actually deploy this code, I'm hitting this, and it runs G-Cloud Workflow Deploy, bit.ly secret connectors, and the source file to it. And deploy is done, so it was a couple of seconds to it. And now actually I need to execute it, and then I need to, the execution is done, and I need to describe in order to see the executions of it. So I have here also the output already finished, so it's very easy. It doesn't have any cold start, it's immediately reacting. Whatever we see here is that we had a long URL, and there is somewhere, it's here the short URL. So essentially, this has been shortened. So the short link is being offered by the API. What we had in the workflow, we had the shorten with bit.ly. We used the bit.ly service. That's a HTTP post call. We had to use an API key, and then the parameters for it, like we want to use the bit.ly domain for shortener, and this is the long URL, and I want to get out the short URL for it. I want to also show you that using connectors, this syntax is using connectors. Here, the syntax is using HTTP calls. By using connectors, you are able to reference other Google Cloud projects. And for example, I had Secret Manager, which is a nice Google Cloud product, where I have under bit.ly API key label my bit.ly API key. That means that I'm able to access it in a couple of lines of syntax. Actually, that's 5 lines of syntax to read out from Secret Manager the API key and to use it in my workflow. So I sequenced 2 tabs. One is to get out the API key, and the second one is actually to run the API of the bit.ly service. There are a bunch of services that you can connect with. This was just a basic example to show you how it works out and how you can do 2 things in the Cloud Workflow section. But let's go further and see what other offers are for Cloud Workflows. Well, essentially, there is the functions. You can manipulate string, JSON, iterating syntax, map. There is a syntax, nice syntax for exist and default and dynamic keys. So essentially, if you want to do all sorts of functions, you have decode, encode, find all this operation in order to actually, in the workflow, in your orchestration engine, to work with the data that you want to process, or you want to create a loop on it, or you want to create a conditional execution, and you have access to all these string functions. Also, I want to reference that there is a new syntax for map get and a default one. So essentially, if you write it here like map get, you write the whole hierarchy of data, and you can eventually check if there is a cache hit key or not. This syntax with map get, it reads out the cache hit syntax, but in case of it's not existing, the default construct is actually returning false. This way you can actually read out from the responses keys that might not be there, because as you know, in the cloud there are many events, and not all events contain all the keys of it, because there are operation based. So you might have 5 events for a full operation, and only some contain some data. Good. Again, what's new in workflow? You can have scheduling and triggers from the UI. So if I jump back to the UI system, and for example, I want to see this cloud storage trigger. So actually here we have right now a trigger section. And this trigger section is something that is the second part of the code, the Eventarc system. But whenever you define a new cloud workflow, you are now able to actually choose here from the trigger like Cloud Scheduler or Eventarc integration, which is a nice addition. And if you do Eventarc, in the right pane, you get all the flow to actually add for all the elements of it. So this screen constantly builds out for you in order to do all the operation for it. So it's a nice addition for this section. Good. Going next, and the same with the scheduling as well. So it's easy to actually schedule a workflow from the UI. You have connectors. I already showed you the connector for the Secret Manager. You have built-in automation, retry, long operation for it. So you can use connectors to actually run long operation objects for different connectors. Connectors actually changed and shortened syntaxes, because with a connector, you just actually type out all these names. You can actually find out in a manual what connectors are available, but pretty much for all Google APIs, there is a connector. If you don't know the connector, then you need to read out the full URL. You need to construct the URL in order to read that data and use, for example, the HTTP GET or POST statement, and eventually decode the response. If it's a payload data, it might be based on base 64 encoding. But here you have 5 rows and 5 lines, and with that 5 lines, you're actually easier to actually access the services as well. Also, the connector details, the favorite is that it has built-in automation. It can have a retry timeout. Long running operation is another one where you want to use connector. You don't need to actually poll the results, and it automatically pauses in order to get the results. Where we are running long running operation, it could be for BigQuery or Cloud Build, or even, let's say, Document AI, because these are the most popular one that people ask me, and I'm referencing to them as well. Good. Callback endpoints. Well, a workflow system might have an external step, and that external step could take days, weeks, or even up to 1 year. This is what we call human in the loop, but it might be a human or it might not be a human in the loop. Callback endpoint lets you to enable async execution, which means that if you reach a certain step, the system can actually stop and will continue from there when you signal it from externally. How this is working out? Well, essentially, you need to create 2 steps. The one step that you actually pausing, and another step where you are resuming. So this step is called create callback. This is the call events create callback endpoint. You have a callback method. You could have here get or post, whatever you prefer, and how do you will signal it back. And the callback details variable where you store these details. And essentially, in this callback details, you will get the URL, and the URL, you will need to ping it later. So when you ping it later, another step will wake up. This is a wait callback. And you have here the definition that this is the continuation of the callback details. You might have a timeout. How long this will await the callback? It can be up to 1 year. And eventually the callback request is going to be the next step, because, sorry, not the next step. Callback request will be the variable that you will process in your next step. So if you go back to the anatomy of a cloud workflow, at some point, you might here do in one of the steps an await callback step, where it means that you are pausing the workflow and you are waiting for the external callback to happen. What this means? It means that if it doesn't happen, it will go into timeout and eventually it will fail. If it calls an exception, it will fail as well, but it will listen. It will listen on a callback endpoint in a HTTP call, and an external system like an event or something, it can request and do a HTTP call on that endpoint. It means that on that endpoint, the workflow will be continued. So this is a nice way to actually work with the human in the loop factor. When you have a step where you, for example, your workflow identified something that you are not assured, and you pass that information to customer service. Customer service logs back on an interface, let's say daily or when they have the office hours, and they clear the fact, or they clear they do clearance to the fact. And then when the clearance happens, your application will signal with an incoming call that this process should be resumed. So essentially, your workflow will continue further and will do the next steps of it. It's an interesting feature. Callback details, it's a modern way to actually avoid sys, sleep, wait, tracking tables, and polling features, which now are of the past. It offers a webhook endpoint secure with authentication, so our application can signal it securely that the process needs to continue. It can configure timeout. It's a wait-based, so actually pauses the workflow execution until the call is received on the endpoint. This is a nice way to actually do workflows, and you can essentially run a workflow up to 1 year. So if you start something today, you can actually wait for the callback or wait actually next year to actually run it and finalize the workflow itself. And it provides also access to headers, query body, raw JSON elements of it, just using the YAML syntax. So it's an amazing way to actually do programming stuff, and you don't need to maintain libraries and major versions, containers, and jobs for it. So this was callback endpoints. Next, there is parallel steps, which was launched recently, and they call it in preview. With parallel steps, you are essentially able to do either steps in parallel, like doing 1, 2, 3 in parallel, or you can do loop parallels where you have, let's say, 10 positions in an array, and for each 10 position, you actually need to obtain the results, and you can you can do that sequentially going over of that loop, or now you can use parallel steps in order to actually see how to run this parallel stuff. So if you want to actually say here, when you have the definition of the step, you add the parallel as an option, and then you can have shared variables of it, and then you define the branches. The branches are the steps that will execute in a parallel operation. This is not the loop base. This is actually running, in this example, 2 steps in parallel. If you are in a loop, then you could have the definition, the step definition, then you have the parallel keyword, you define the for, you define the input, and the variable that will be looped together. And then you have the steps, what you want to do with that variable as well. In this example, you could have a notification to somewhere, or you could actually better construct this. You could have in the notifications like people who want to notify, and you can actually parallelly loop all the people who need to be notified or all the entries to be notified in a parallel way. This is an awesome way to actually do something much more quicker and instantly and not sequentially after each other. Good. If I go back to the presentation, finally, and sorry for those who actually waited for the Eventarc part, I had to introduce workflow before. For those who don't know nothing about cloud workflows, now we are going to talk a lot about Eventarc triggers for workflows. So essentially, let's dive deep into this trigger workflow using Eventarc. So Eventarc, well, Eventarc is a system that is an observer system, and when it observes something, it emits or has a trigger section of it. So it has an input and an output. We could, if you need to give a name to the service, it delivers events from Google services, SAS services, or your own apps as well. So anything which leaves a log, it can be used as a provider into the Eventarc system. And for Eventarc, we have providers and we have targets. For providers, there is Google Cloud with more than 90 providers, but this is growing as we speak because they enabled Eventarc for, I think, all of the products now. You could have your own apps. And essentially, some of these are work with together with PubSub providers. So essentially, there is also a transport layer, because often I get the question like, what is the transport between the provider and the target? Well, the transport is the cloud PubSub system, but it's automatically managed by the system. So even if it's there, you just need to understand that this is a cost component in this element of it, like running all the events through PubSub. Good. On the right side, we have targets. Currently, we can name 3 targets, but they are constantly adding new. I could have here also Cloud Function as a target itself. So you could have Cloud Run workflows or GKE to actually run any targets. But if you have workflows, with workflows, you can further add whatever target you want. So essentially, we don't need to actually wait another service or another integration, because the workflow system automatically can be used. And further, you can add here any target that you want to use for your Eventarc integration, like your own API or your own endpoint or your own external service or internal service, whatever. Good. So what is Eventarc? Eventarc is an asynchronous event delivery service from different event sources. Users can manage all their triggers in one place. So essentially, the future is, or the current times is, that in your cloud applications, you might have triggers. And these are not database triggers, because there was a confusion at some past event that this is not a database trigger, it's a service trigger. And now users actually can eliminate all the little code, DevOps code or automation code from cron jobs and so on, and manage their triggers in one place. So essentially, you could have either the scheduler or the Eventarc to actually have the trigger in your systems. About the pricing, because this is also a managed service, it's on the Google Cloud Platform. You don't need to set up any service. You don't need a sysadmin. All this is serverless, so it's run for you very, very easily. The pricing, internal, it's free. I didn't wrote free because they added 0, so at some point they might increase this cost. It's important that right now it's free. What it means internal? It means that all the Google Cloud Insight log entries, audit logs, events are free to actually process it. There is the external one. External has $1 for 1 million events. I would say that this price is almost free, because 1 for 1 million is almost free. But we don't need to forget it that there is a transport cost, and that's according to the POP/SOC costs. I don't want to expand more on the POP/SOC cost, but this is based on access and also by bytes. So how long, how big, how large is your event? It can add a POP/SOC cost. Also, please be aware that POP/SOC offers 10 GB of free transport costs each month, so you might fit into this system. But if you are let's say the next Spotify, then you would have a lot of costs if you want to run all the events to the Eventarc system on the POP/SOC side. And I added here potentially unlimited event sources. Why I added potentially? Because anything which can leave a log or leave an audit log, it's an unlimited way to actually reach event sources for an Eventarc system. Good. It's fully based on Cloud Events IO. We'll see what this means in the next slide. And of course, it integrates with Google Cloud products without worrying about authentication. So there are some roles here, but they get sorted out with the service account key as well. So what's this Cloud Events? Because we didn't discuss the nature of events. Well, Cloud Events IO is part of a foundation, and they have defined a lot of events eventually. If you don't know the service, you should check it out. So eventually, we have here the integration. It could be Adobe, Alibaba, Argo, Azure, Google Cloud. It's all centralized. So essentially, if you go to the specification and you try to find out here, for example, the JSON event format, because this is the one that we are currently using, you have here the definition and the format as well for constructing the base event of the JSON. But I say that this is documentation. Let me show you visually. So it's a JSON. So essentially, the cloud event is a JSON. And if I go to the next slide, we have a context area where you have the context area, and we have a content type of it, and then you have the data section. Essentially, in Google Cloud, 99% of it, you will use the data section. In the context section, you will eventually use the time for it and eventually use the ID of it. And the application type, if you want to do only custom types, because 99% of the events, it will be application JSON. But it might be a situation that when the content type for your event, it could be something different for it. Good. And now the most curious part, because we are here to actually see some Eventarc events, and I'm going to show you right now. So this is a minified JSON. So I took out some lines in order to actually leave the essence of an event. And let's see what this is an event. So this event is for a cloud storage event for an uploaded object. This is called Google Cloud Storage Object V1 finalized. This is the event. And essentially, this file was uploaded to a bucket of it. This is the time. This is the subject, what was uploaded, and the rest of it is data part of the definition. And you see here the data. Well, essentially, this data changes on Google Cloud based on every service and every type, event type that it gets used. So in this situation, cloud storage details are in here. In the next slide, there will be BigQuery operations here and attributes to it. So essentially, you will see here that the file was uploaded to which bucket, was the content type. It could has an ID and a kind of it. It has a media link. If you want to, for example, place this into an email, you can read it out. This is the name of the file. You could have a self link if you want to access it authenticated with the IAM rows, the size of the file, the storage class where it has been uploaded, and the time that hence it happened, all this. Good. Next, I brought you another event as an example. This is BigQuery job service insert job. If you are on a BigQuery, you know that everything is a job. And essentially, this is where we need to pay attention to actually having multiple events, because inserting a job, it might be not the final thing of it. So it might be multiple events of it. So essentially what you see here also as well, that this type is based on audit logs. Well, I didn't tell you so far that Eventarc actually has many ways to identify an event. One is direct one, when the previous one from the storage system was a direct one. The storage system directly emitted an event, but the others are available based on audit logs as well. So the audit log, it might be, for example, just accessing the data or accessing a table, let's say in BigQuery, and it could result in an audit log. So you could have an event who emits you when a certain table was accessed by someone new. You could maintain in a list of people that you access that table, let's say, and store in Firestore, the list of it. And whenever there is a new entry, it can alert you that someone new has accessed the new table in BigQuery. Well, that's an audit log. And I wanted to actually show you is that the method name is BigQuery job service insert job. So this is a subsection of the audit log. And the data schema, for example, this link is clickable, but not in my slide. But this data schema is actually, it will show you all the schema of the data that's in here. But this data is so big that I included only the main parts of it, and I collapse it in order to show you what's in here. So essentially, mind the timestamp long name, you could have an operation, and the operation could have a key of last, true. You know, you might know in Google Cloud that there are many events, and you can have a keyword for last, and that's the event that you want to actually process. In the proto payload, it will be the rest of the data for the job that you have executed, and so on. So my next slide actually expands on proto payload. So let's see what's in there. So we have data proto payload. So in the proto payload, we could have, for example, the query that has been executed on BigQuery. It could have the output row count, how many rows was outputted by using that query. It could have the total bytes build, which is close to 10 gigabytes, start time, and the job state, if it's done or not. Remember, it's an event-based system. You may have here a job state of running, but you need to actually look out after keywords like after done or job state done as well. So you need to filter it out. We are in an async world where you have multiple events of it. Good. Now, I want to stop here a bit and actually show you code and show you example of it. So we are going now to the Eventarc system. Eventarc is here. You could have a trigger, for example, for the cloud storage new file. You could have a provider. The providers here is endless list. So I'm saying that it's potentially unlimited way to actually reach out all the events. So you need to use the cloud storage. Which event? I'm going to see here buckets. Where was that? Archive finalized. So object finalized. I can search for my buckets. Like for example, this bucket is the one that's being monitored. Event destination could be Cloud Run workflows. I could select the workflow, cloud storage trigger, and I should hit create, but I already pre-created this workflow and this trigger for you. So essentially, if we go back, we have here bucket new observer, which is already set up, and it will call us a specific for workflow destination cloud storage trigger. Yeah. So this workflow, it will be executed for us. And also the workflow, this has been set up yesterday by me in order to show you example, and the workflow is set up. So let's go how the workflow looks like. Let me close this. Cloud storage trigger. It's here, clear, good. So what we have in this workflow, log, send email. Let me show you like this. So we have a step to log the event. Well, essentially we get an input param like an event. We have a step for logging the event. We have a step to extract the bucket and the file name, and then we send an email. I have a sub workflow for SendGrid to actually send it an email. So essentially these are the parameters. This is the HTTP link URI constructed based on the secret manager to get the payload data, to get the SendGrid API key. And this is the URL to actually send the email. And in the body, I have all the elements of it. You may wonder, what are these? If you are first time here, these are JSON construction. So essentially, I'm setting a personalization or from subject content keys of the JSON object of that, and automatically it will send me the email. So this is sending the email. Good. If I expand log the event, I'm simply logging the event. Then I'm extracting bucket and file two variables. And then I call the SendGrid sub workflow. I'm using this secret label in order to fetch the API key. This will be the from, this will be the to as well. Subject content, and here in the content, I put bucket and file. So essentially now, if I go to storage, where is storage? Here. And if I drag and drop a file, hopefully not that like that. I want to upload or refresh. Where is upload file? Desktop, Vertex AI. So this file is being uploaded, and I should get here, but this interface is a bit laggy. I should get here an event. It usually shows up in about 1 minute. But I can check also the execution of the workflow, and the execution just happened, so it took 1 second. And if I go into my mail, it should be in the spam section because I didn't set up any authentication. And yeah, so we have here my email. A new file has been uploaded to cloud storage, bucket, file. Sorry for not formatting this, but that's a basic example of sending an email as well. Good. So what happened is that there was an Eventarc system that is being monitored. It's monitoring a bucket. I placed the file, and that actually fired this workflow, and the workflow itself logged the event. Let's see the event because that's interesting as well. So if you go into the execution, we have this section. Let me copy that and put it here. So this is the full event, and you can actually take out from here any parameter, any attributes that you want to actually use it. This is a simple event. It's not that big one. We could also do some BigQuery example. I've set up also an Eventarc system. Where is the second one? I set up here BigQuery insert job. So essentially, I wanted to create a trigger to fetch and to obtain all the events when there is a query being executed. And I want to see and signal queries that take a long time or access a lot of data. So essentially, I can use an insert job trigger, and I can wire that to a destination, which is also a workflow itself. I've been testing a lot with this. In the event data, you will see that this is a really long event data. So essentially, you will get all the details in it. For example, what fields are being obtained or read, which columns are read from the table, or for example, this is an info. If this is an info event, this is an info event. There is another event because there are many events that actually fire here. Let's see this one. Info event. Yeah, this is the query. And here, for example, we can see the query itself. We can see the total bytes and processed bytes, and we can pick out certain keys from this. So let me show you the workflow because the event and to trigger it is easy. Again, we have log event in order to see the full event. Then we have a check in order to see if it's the right event for us or not. So I'm using a not job event. So sorry, if it doesn't have a job change event in the metadata, I'm ending this workflow. And I'm proceeding only when there is the job change event. And from the job change event, I can read out job status, the query, cache hit, total byte processed. So these, what are written here long, event data, proto payload, metadata, job change, job status, is actually from the hierarchy structure of data, proto payload, metadata, job change, job config, query level of the data in order to print the event. I'm also sending this event. So if I go quickly to BigQuery and I'm running a query, let's run 2. I want to actually change here something just to, usually BigQuery caches the query, and this one takes a bit longer because I didn't touch that syntax before. So I expect the workflow to actually send me 2 emails. One event is finished. This was the cached one. So a new query has been completed. Cache hit true, total byte 00, and this was the query which was cached. And hopefully here you have the other email which wasn't cached, which were 6 and 6. Here we have cache hit false, total bytes in bytes, total gigabytes, almost 10 gigabytes of it. Essentially, what I wanted to say and show you is that further here you could add additional conditionals. You could have a condition that only alert and send emails where, for example, you touch and run queries which are on a certain trigger threshold. So basically, you could alert for large queries or people touching data that they are not supposed to, or they are first-time theirs. Good. I'm ending my talk right now, but I wanted to actually show you some follow-ups and some takeaways. So I wrote a couple of articles on Medium where you could have Firestore Backups, the easy way with cloud workflows. You could have a scheduler trigger a workflow which runs a backup action on Firestore and places the file on cloud storage. Full article on Medium. Another example to load cloud storage files into BigQuery. So essentially, you have the cloud workflow, you have cloud storage, you have the event, and for each file, it's being added to BigQuery as well. You can refer and extract file names out of the table names or column names out of the file in order to use it as a custom destination table as well. Article on Medium as well. And Eventarc as well. The Google Cloud team and Meta, Google Developer Relation, has actually published a nice image processing pipeline, CodeLab. You could try out to actually place an image on cloud storage. It does a processing to add actually a watermark, a resize, a labeler, and a filter, and then produce the output image for it. And all this to learn what is Eventarc, how Eventarc triggers the workflow process, how to deploy cloud function, how to orchestrate services using workflows. This is on CodeLab, so it's free, and this is the link to actually get to it. You can have other examples on CodeLab if you search for Eventarc, with a lot of examples there. And also there is this page, let me find it somewhere because I bookmarked for you. So there is this Google Cloud Platform Eventarc samples repo on GitHub, where you have a bunch of Eventarc examples already prepared for you as a link to reference of it. Either if you are using Cloud Run, Cloud Functions, or Workflow, or even Terraform samples, these are available for you and you can check it out. Good. And finally, conclusions. I don't want to spend too many times. If you have any questions, shoot in the chat. I'm monitoring constantly. So conclusion, it's extremely developer friendly, potentially unlimited trigger events, which is nice if you consider that all the events are available in the Eventarc section. So I could call that we have access to potentially unlimited trigger events. It's easy to build and operate. You see just a couple of lines of syntaxes and setting up triggers. It does not lose state. So if you run, for example, a year-long workflow action, it will not lose the state, and even it will be there after 11 months. It scales out. I didn't mention about scalability, but it automatically scales out as you add content to it. handles errors and timeouts. So you could actually write a much more complicated workflow system to actually take care of error and timeouts. But if you are using connectors, those have actually inbuilt elements to handle retries and operations for you as well. Out of the box support for cloud APIs, anything which is a cloud API, it's auditable. If you have a need for a project in a financial or regulated, let's say, aviation industry, workflow is auditable. It enables async workflow with callback, so you can have a human in the loop factor, which is a nice addition. Compared with the auditable, it's a nice addition as well. Well, essentially, from marketing, retail, industry, developer, you could have a lot of ways. You could automate the cloud. You could have a share script replacement, orchestrate DevOps workflows. You could have a digitalization of internal policies, workflow-based maintenance needs, like you could schedule in the next 4 months to run some items for you, generate state machines. A lot of data that you are managing is available as an event. It's available in a workflow engine and can be automated for you by the orchestrator. And the orchestrator in this situation is Cloud Workflows. So essentially, this concludes my talk. Thank you for being here. I see that you have 64 people in here, which is nice. So thank you for being here and to attend my talk. If you have any questions, use the chat. And if not, I'm available on Twitter. So you could use this Martin Kodok as in the Twitter as well. You could ask me things. I will shortly upload the slides to SlideShare. So you will have available all the examples and the syntaxes that you have run it. Thank you for having me here and run this presentation for you.